We will now look at an example to learn how to tackle a problem if you are unable to find optimal solution in assignment. Well, we are given a matrix again which represents cost, and we have got 4 jobs to be done, 1, 2, 3, 4, and we have got 4 employees who are capable to do these 4 jobs. So since cost is given to us, we know this is an example of a minimization problem, and since you have 4 rows, 4 columns, the number of rows equal to number of columns, which means this is an example of a balanced problem. So we directly start with the first step, which is reduced cost table number 1, which we also call it as row minima. So our 4 jobs are 1, 2, 3, 4, and our 4 employees are A, B, C, D. Right? These are the 4 jobs, the 4 employees. We begin with the same procedure. The first row, the least cost, is 59. So let's keep subtracting. 61 minus 59 will be 2. 87 minus 59 will be 28. 59 minus 59 will be 0. And this will be 6. Second row, the least cost is 42. This will be 42 minus 42, 0. This is 2. This will be 27. This will be 52, 62, 72, 36. Third row, the least is 47. So 47 minus 47 will be 0. This will be 7. 54 minus 47. This will be 33. 80 minus 47. And this will be 57, 67, 20, 17. Let's come to the last one. The least is 65. So 0, 0. This is 68 minus 65 will be 3. This will be again 0. Alright. This is a crucial step wherein you need to cover all zeros with minimum possible lines. First of all, in this particular sum, you looked at in the very first reduced cost table, wherein definitely all the rows will have 1 0 because we have done row minima. Look at the numerical carefully. The first row has got 3 zeros, second row has got 1 0, the first column has got 3 zeros, second column has got 1 0, the third column has got 1, fourth column also has got 1, which means in the very first step, row minima, we are able to achieve zeros in all the rows and all the columns. Since all the columns have got zeros, at least 1 0, I need not proceed for the next RCT. The very purpose of going to a second RCT reduced cost table 2, that is column minima, is to ensure that every column has at least 1 0. Now that every column here already has at least 1 0, we need not proceed for the next step called as column minima. So we directly work here. So we need to cover all the zeros with minimum possible lines. Look carefully. If I am able to draw a line like this, with one line I am able to cover 3 zeros, 1, 2, 3. And if I draw a line like this, again with one line I am able to cover 2 zeros. Now I am left with a 0 over here. So either I can draw a line like this covering the first row, or I can draw a line like this on the third column. Either ways I am able to cover this 0. So let's say if I draw it like this, both the ways you are allowed, the answer will be the same. So let's say if I draw a line like this. Now look at it, all the zeros are already covered, which means here the minimum number of lines covering all zeros is just 3. 1, 2, 3, or other way around, 1, 2, 3. But the matrix size is 4 by 4, which means this is not equal. So if it is not equal, you cannot proceed with assignment. Why is that? If it is not equal, you cannot proceed with assignment. If it is not equal means not all the employees will get one job each. Maybe one employee will be there who will be jobless. Which means unless and until this particular condition is satisfied, we cannot proceed ahead. So here, since this particular condition is not satisfied, mind well, if you draw lines like this, 1, 2, 3, 4, you are wrong. If you draw lines, 4 lines covering all zeros, you are able to cover all the zeros. But the number of lines will not remain minimum. The number of lines will be minimum only when you cover in this pattern, wherein it will be 3. So how should you now go ahead? What will be the next step? Let's say now RCT2, and it will not be column minima this time. 1, 1, 2, 3, 4. Okay, our 4 jobs, and our 4 employees will be A, B, C, D. Alright. When you are in such a condition, how to make the next RCT is the question. What we will do is, out of all the unmarked numbers, unmarked number means जहाँ से कोई line pass नहीं हो रहा है. Out of all the unmarked numbers, the least is 2. So I'll write out of all the unmarked, the least is 2. ये 2 को रख के क्या करना है? With this 2 or with the least unmarked number, what you will do is you will add wherever you have got intersections. Now what is intersection? ये line दोनों intersect हो रहा है. So wherever you have got intersections, you will add this 2. Wherever the numbers are unmarked, ये 2, 27, 36, 17, 33, 7, ये सब unmarked है. Wherever you have got unmarked, उधर you will subtract this 2. And wherever you have got all other marked numbers, those numbers will remain same. I repeat, what we'll do is, out of all the unmarked numbers, we consider the least unmarked. So the least unmarked is 2. So I write unmarked mein least is 2. Wherever you have got intersections, here there is an intersection, here there is an intersection. Wherever there are intersections, you will add this 2. All those unmarked numbers, you will subtract this 2. And wherever there are marked lines without any intersections, only marked, the numbers will remain same. So let's work. 2 is an intersection. So if it is an intersection, you add. What to add? 2. So 2 plus 2 will be 4. 2806 are marked ones. So the numbers will remain same. So 2806 numbers remains same. 0 is marked. So 0 remains same. These 3 numbers are unmarked. So whenever it is unmarked, we subtract. Subtract what? 2. 2 minus 2 will be 0. 27 minus 2 will be 25. 36 minus 2 will be 34. Third row, 0 is marked, remains as 0. These 3 numbers, 7, 33, 17, unmarked. So if it is unmarked, we subtract. 7 minus 2 will be 5. 33 minus 2 will be 31. And 17 minus 2 will be 15. The last row, we have an intersection here. So with 0, wherever there are intersections, we add. So 0 plus 2 will be 2. All these 3 numbers will remain same because these are marked. So 0, 3, 0. So now we have a new reduced cost table that we have obtained with this procedure, wherein we took the least unmarked numbers, added intersections, all unmarked, subtracted, and all the other marked numbers remains same. Now with this matrix, we now again try to check if optimal solution is possible. How? Again, your task is to cover all the zeros with minimum number of lines. Alright? So now, The first column has got 2 zeros, so I can cut it like this. I am right. The second column has got 2 zeros, so I can cut the second column. There is 1 0, there is 1 0. So either I can cut all the 4 columns, I repeat, cover 2 zeros, cover 2 zeros, cover 1 0, cover 1 0. Or else, let's say if I cut this, cover 2 zeros, cover 2 zeros, cover 1 0, cover 1 0. In both the case, the number of lines remains 4. So let's say if I cut it like this, 2 zeros, first preference to rows or columns where I've got maximum possible zeros. So let's say if I cut this one, there are 2 zeros, one line like this, one line like this. There can be different patterns when you draw lines. Not necessary that two students will have the same kind of lines. But one thing is very clear. In this matrix, I am able to have 4 lines, which becomes minimum possible number of lines. So minimum number of lines now is 4, and now the matrix size is also 4, which means optimal solution is possible. Now if optimal solution is possible, let's go for assignment. You know that when we go for assignment, we look row wise, first, second, third, fourth, then we come column wise if required. We give preference to rows or columns where the number of zeros is 1. Single zeros जहाँ पे भी है, उन rows और उन column को पहला preference देंगे. First row has got only 1 0, you allocate. नीचे कोई zero नहीं है, रहेगा तो वो cut हो जाएगा. Second row has got 2 zeros, you put on a hold. You put on a hold because second row has got 2 zeros means what? This particular employee B can be given job 1, he can also be given job 2. He can be given either one. Okay? But if I look at C, he can be given only 1. That is the reason that whenever you look at rows or columns, give preference wherever there are single zeros. Now here there are 2 zeros, put on a hold. Now here there is only 1 0, third row, so I allocate. Which means to employee C, I give job 1. So C ko if I give 1, 1 cannot be given to B. Automatically what remains for B is 2. So if I give this 2 to B, this 2 cannot be given to D. So this gets cancelled. So what is left for D? That's it. Which means the optimal solution goes like this. Let's say your employee A will be given job 3. Okay. So A, 3. The cost of the company is 59. Employee B will be given job 2. So if B is given job 2, cost to company is 44. C will be given job 1. So C is given 1, cost to company is 47. And if D is given job 4, cost to company is 65. You add up these numbers so that you get the total, or I can even say total minimum cost. So that makes optimal solution for this particular problem, wherein in the first step we could not find optimal solution because the number of lines covering all zeros, minimum number of lines 3, was not equal to the matrix size. So this is how we tackle a problem whenever you find that optimal solution is not possible. In the next example, we speak about a maximization problem. So wherever you've got sales, wherever you've got profit, you'll have to make something called as a regret matrix, which we also call it as opportunity lost matrix, which is a part of maximization problem. The first example, second, and this one, all the 3 were example of cost. Therefore, all these 3 sums pertain to minimization. In the next video, let's look about how to solve a maximization problem. Thank you.